Hey, welcome back to BensTechLab. I've been recently exploring these Chinese motherboards. This motherboard here goes by the brand name Machinist and is a Machinist X79G version 1.3. These are rather inexpensive and they are remanufactured. That means they have recycled old server hardware, removed the existing X79 chipsets, and built them into brand new manufactured motherboards. So the chipset on here is manufactured in probably around 2013 era and has been removed from some decommissioned server hardware and then built into this new motherboard. The motherboards are quite inexpensive. This one sells for around $70 US. That was shipped to my house, so that's a pretty good deal. And the question is, will it handle the TDP processor that I want to use? So in the Xeon E5 lineup, there are processors all the way from like 65 watts TDP package rating up to the 130s, 140s, or something like that. The processor I've gone with on here is an Intel Xeon E5-2650 V2. That is an 8-core, 16th thread processor. It is got a standard clock speed of 2.6 gigahertz, and it can turbo up to 3.4 gigahertz for a single core turbo and up to around 3 or 3.1 gigahertz for an all-core turbo. So the question is, will the VRM solution on this motherboard and the VRM cooling solution keep up with a 95 watt TDP processor? That's what we're going to find out today. All right, so what I've got going on here is my basic thermal test bench. This room is a tad warm. My house thermostat will be set to 71 degrees Fahrenheit, which is around just under 22 degrees Celsius, 21.67 or something like that. The temperature in this room right now is reading around 23 degrees Celsius. This machine has been running all night long, and so therefore is saturated with its kind of idle temperature heat. And what I've got here is a K-type thermocouple with my multimeter, so I can do some basic temperature measurements. So my first goal is just to establish how accurate the reported temperatures from the motherboard are in the operating system. The BIOS does show that we've got CPU temperature and a system temperature. Let's see here what we got. So it's got an IT8772E hardware monitor, and it's reporting a CPU temperature of 34 to 35 degrees Celsius and a system temperature of 43 degrees Celsius. So let's see how that compares to some of the hardware on this board. So first off, the further away you get from the actual heat source, the lower it will measure. So I would expect it to measure quite a bit lower when we're, let's say, on the outside of the CPU cooler versus the heat spreader itself. So if this is accurately reporting temperatures on the motherboard, then I would expect these temperatures to be slightly higher than what I actually measure. Some of these off-brand remanufactured motherboards have been reported to under-report the temperature, make it look better than it is thermally, or to have a large offset, like a 30-degree offset. This looks at first glance like it's probably accurate, so let's see how far off we are. So my little thermocouple here is starting, it says it's 25 degrees Celsius in here. Seems a little high compared to what my watch was reporting, but we'll see how that goes here. So starting at the outside of the CPU cooler, I would expect this to be a few degrees lower than the actual CPU temperature. It's reporting 29 degrees Celsius, 30 degrees Celsius, while the motherboard is reporting 34. But that is at the furthermost part of the cooler, and the fan is running, so it's actively cooling this as we measure it. So let's try to get something in on the heat spreader down here. Okay, now we are making contact with the heat pipe, one of the heat pipes on the heat spreader right at the base of the processor, and we're getting spot on here. It says 35 degrees Celsius, BIOS says 35 degrees Celsius for the CPU package. We're pretty well spot on the CPU temperature as far as I can tell. So next temperature reported in the BIOS here is system temperature. I'm not sure whether that relates to the chipset or the VRM, or if it's a separate cooling or temperature reading just generally on the motherboard. But let's poke around and see what we got going on here. So starting with the chipset. Chipset is pretty toasty. I'd say it's a little too hot to touch. We're getting in the mid 50s here. We got 53 degrees, 54 degrees Celsius. 55. So yeah, we're hitting 55 degrees C. I wouldn't expect that to change a lot under load versus not under load. We're not putting a lot of work through the chipset. The components that are going to heat up the most is going to be the processor, and as the processor draws more power, the VRM. So let's take a look at what the VRM is sitting at right now. So this VRM is a little toasty. We are sitting at 54 degrees, 55 degrees Celsius. Which is not bad. We're well under 60 there, but it is a little toasty. And so the question is, when the CPU gets under load, how much higher is that going to go? And would it make sense to put a case fan or some other auxiliary airflow over that heatsink? Or is it just not going to be able to keep up with the cooling of a 95-watt TDP rated processor? While I'm here though, let's do a few extra measurements. We've got a fanless GPU, which is a GeForce GT 710. This is essentially going to be a headless server build, so I don't need graphics performance. It's really just for interacting with the console, getting things set up, debugging, that sort of thing. So that's totally okay. I've also got a fanless HDPlex 200-watt AC-DC power supply solution. This is a two-component solution. So there's a power brick here, which converts the 110, 120 volts AC to 19 volts DC at 200 watts. And that's fed to this other component, which is the DC to ATX converter. A lot of people will be familiar with the Pico PSU, which is a common industry solution. This one is just a little bit more premium than that. The Pico PSU, I believe, tops out at 150 watts capacity. This one goes up to 200 watts capacity, so you got a little more headroom on there for some more performance components. Again, I've got a really low power GPU, so primarily we're talking about the CPU power package here. This CPU being 95 watt TDP rated. If we add 20-30% to that, I'm hoping the system doesn't draw more than maybe 120 to 150 watts at the most, and leaves lots of headroom on this power supply as a fanless solution. So let's take a look at what we've got on here for temperatures. The power brick itself is sitting at 38 degrees Celsius, 39. It's pretty good. And then we're going to measure on the DC-ATX converter right on the HDPlex logo here. And we're sitting at around 36 degrees, 37 degrees Celsius. So similar to the power brick, just hitting 38. Not bad. 39. Stabilized there, seems to be right at 39. That's the outer face. There is another heatsink on the inner face here. We'll just take a quick reading on that. Sitting at 36 degrees Celsius. And last but not least, let's check out the GPU here. Fanless GT 710. Sitting at 36 degrees Celsius. Totally fine. All right, let's get back to Windows for some benchmarking. Okay, so this is a stock Windows 10 install. I did run Windows Update once just to pick up all the drivers from the motherboard, but other than that, there's not much on here. I have added hardware info 64 here. Do a little bit of monitoring. We'll run it in sensors only mode. Take a look down here. You can see the CPU core max is right in line with what we are measuring. The cores are pretty cool. CPU package temperature reports a little bit higher here. That'll be the total package. And again, what I measure on the heat spreader outside of the CPU is going to be lower than what's in the internal CPU package. It's just the nature of the heat transferring through that thermal interface material, the heat spreader, and into the heatsink. But I'm not worried at all about that. This Xeon E5-2650 V2 is rated to go up to 75 degrees Celsius. Obviously for longevity, it'd be better to keep that a bit lower. So we'll see how this goes when we put it under load. It is reporting a minimum of 22 watts power consumption on idle, and it hit 47 watts just doing Windows boot. So that's not a lot of load, but there is some work being done there. And system temperature. So this is right in line with what the BIOS was reporting. Temperature 2 here is going to be the system temperature. I don't anticipate this one to climb as much as the CPU itself, and therefore the VRM. All right, so I've also installed Cinebench R20 on here to do some testing. This should peak all of the cores into a all-core turbo boost and load them up really nicely. So we'll be able to see what kind of thermals happen when we do that. So we've got our hardware info 64 here. We've got some graphs going for the system temperature, CPU package temperature, and the core max temperature. So you can see how that behaves as the load progresses. So you can see we've got 16 V cores going on. So that's 8 cores hyper-threaded to 16 threads. And it is currently sitting at 1.3 gigahertz or so, just puttering away, doing whatever the little things are that Windows likes to do in the background. So let's put some load on this thing. All right, so you can see all 16 V cores are being pinned at 100%. We are getting an all-core turbo boost up to, well, it says 2.99 gigahertz on the Windows performance monitor here. Let's see what hardware info is reporting. 3 gigahertz. Maybe a little bit of rounding there. That's pretty good. This processor can turbo boost up to 3.4 gigahertz on a single core, and then it scales back the more cores that are under load. So 3.4, it'll drop down to 3.3 on probably 2 cores, and maybe 3.2 on like 4 cores. And then when all 8 cores are turbo boosting, it's dropping down here. We've got 3 gigahertz. That seems respectable to me. Because I am using this as a home lab server, it's unlikely that I'll actually pin all of the V cores at once. I'm going to be virtualizing and or containerizing, and so generally speaking, some of the cores will be doing different jobs than other cores, and it's not likely that they're all going to be pinned at the exact same time. So having that 3.4 gigahertz turbo boost on a single core can be helpful when a single one of your containers or VMs is trying to do some little bit of work when the other ones are sitting idle. So we can see that the CPUs hit 62 degrees Celsius on the package temperature, 52 on the maximum V-core temperature. I have full faith in the CPU's reported temperature as being 100% accurate. We saw that in the BIOS there with the original tests. I'm also not worried about a 62 degrees Celsius peak on the processor package. That is well within spec of this processor, which is happy to go to 75 degrees Celsius. Obviously, keeping it a little lower is going to be better for the longevity of the processor, so happy to see that a little bit lower. That's dropped pretty quick here. This heatsink is quite nice. This is the 𝗧𝗪𝗡𝗡𝗘𝗟 UH-U9S or something like that. And had no problem recovering after that load test completed. Let's go back on here. All right, but let's see how this VRM is doing. Is it keeping up? Let's see if we can get this in a way that you can see the screen here. All right, so VRM is sitting at 54 degrees, 55 degrees Celsius after that test. Not too bad. I'm going to run it a couple of times back to back here just to see if it is going to accumulate heat as we go, if it's keeping up with that heat dissipation, or if it's just that it didn't have that long of a test to begin with, and so therefore it hasn't heated up enough yet. But before we run it a few more times, let me just check on our power supply here. Still humming away, 41 degrees Celsius. So it went up 2-3 degrees, maybe 4 degrees. Really not bad though. This system is not stressing this 200 watt HDPlex fanless solution at all. DC-ATX converter on the ATX connector here also went up 1 or 2 degrees, not much though. 39, oh, just hit 40 degrees Celsius. Not much higher than before the test. The back plate on the same DC to ATX converter, 37 degrees Celsius, right in line again, maybe a degree or two higher, but not much. So I have a lot of faith in this HDPlex fanless power supply solution. Let's take a look at the chipset. Stabilizing here. Let's see if it calms down. Looks like it's reporting 53. Oh, it just went to 54 degrees Celsius. Pretty much in line though, and that's what I would expect. I wouldn't expect the chipset to get much hotter because we're not putting work through the chipset right now. So even though that's a pretty toasty chipset at 54 degrees Celsius there, I'm okay if it stays at 54 all the time. That's not going to be an issue. So what we're going to do now is rerun the Cinebench and see how much hotter we can get that VRM. Maybe we'll run it a couple of times back to back here. Here, I know what I'll do. Let's run this. And let's see if I can get this in here during the test. There we go. All right, so we're starting the test. We're sitting at about 48 degrees Celsius, quickly going to 50, 52. So this is definitely demanding. Right now we've got an all-core turbo boost. So we've got all 16 V-cores running at 3 gigahertz. The CPU will be maxing out its power draw likely. Here, let's see if we can see that. CPU power package. Let's see. Well, we're hitting 86 watts of power draw on the CPU package here. Not bad. It's a 95 watt TDP rated package. From the wall, we're seeing 125.8 watts peak power. Not bad at all for this home lab server. Keeping this thing on all year round is likely the equivalent of keeping on a 100 watt light bulb, considering I won't be running it at 100% pinned CPU cores all the time. So that's fairly inexpensive. I am lucky to live in the Pacific Northwest, and we have really cheap hydroelectricity here. It's also clean electricity, not coal-fired or anything like that. So I have no issue with running 2 or 3 of these Xeon E5-2650 V2s. So the VRM has gone up to 62 degrees Celsius. We are breaking that 60 degrees Celsius range, but we're still okay. You know, if it maintains this temperature, you could probably leave it as is. If it gets much hotter, you might consider putting a case fan on the solution just to keep those components a little cooler. Might not be required, but it could certainly increase the longevity of your motherboard. Looks like we peaked at 64 degrees Celsius on the VRM. The test is over. You can see the CPU core's load has dropped back down. The CPU package speed is dropped back down. We're hitting back to that 1.3 gigahertz size. Clock speed here, not much for it to do. And the VRM is recovering, meaning the temperature is now decreasing, not increasing. So it does look like the peak was 64 degrees Celsius on the VRM. Let's go ahead and run this again back to back and see if we get higher. So running a back-to-back test here, we didn't give it much time to cool down. We just want to see if this VRM cooling solution is going to keep up with the heat dissipation or whether it's going to keep accumulating heat. We are getting a few degrees higher here. We hit 65, 66 degrees Celsius. Oh, struggling to hit 67, but we're getting there, 67. Got a 68 degrees Celsius, so we are definitely still accumulating a bit of heat. Now in my application, I'm not anticipating having all cores being pinned at 100% all the time. Because these are a home lab server, I am going to be doing virtualization and containerization and probably chunking out cores to various tasks. We did hit 70C though. That is pretty toasty. So you might consider putting a case fan facing this VRM here. Recovering right away though. Test is over. It's starting to drop. All right, not comfortable to hold that thermocouple there for too long. That is an awkward position. All right, overall, I'm really happy with the test results of this motherboard and CPU combo. The VRM did keep up with the power requirements for the Xeon E5-2650 V2. We were able to achieve an all-core turbo boost of 3 gigahertz. That seemed to have worked just well. We ran a few back-to-back tests of the Cinebench R2 to check out the thermals. We did peak at that 70 degrees Celsius on the VRM, which is a little toasty. So if you're going to be running this type of server build with a high workload all the time or a long duration workload, you might consider putting a case fan at the top of your case to blow down across the VRM components and into the CPU cooler and exhaust out the rear of the case. That should extend the service life of the motherboard itself and make sure that you don't run into any stability issues under long duration high loads. In my case, because I'm doing virtualization and containerization, it's unlikely that I'm actually going to pin all the cores to 100% at any given time, but I might still consider putting that case fan there for good measure. So I think I'm ready to go ahead and select the cases that I want to use for my home lab server builds, and that's going to be fun to do. If you like this video, go ahead and leave it a like. If you want to continue to see what I'm doing with my home lab server builds, then consider subscribing to the channel. But that's going to be all for today. See you in the next one.